So thank you all for joining today. I first want to introduce Karina Lansing, who is the chief architect for the pipeline that we are building, and Max Levin, who is the lead software developer. Karina is the architect for several other frameworks that she's created for the atmospheric radiation measurement program. Max Levin joined us about a year ago at PNNL, and he's been helping us with this project. First off, I want to acknowledge the Water Power Technologies Office, part of EERE, that funded us to do this work. And I would also like to thank PRIMRE team for helping us do the two-part series. Even though we are part of primarily developing the data standards and the data ingestion pipeline as funded by the Water Power Technologies Office, I would like to acknowledge the larger ImageKit team and the project members from NREL and Sandia. They play a huge role in helping us with the data standards, since they know a lot about the domain and rely on the larger PRIMRE team to come up with the data standards as well. We have been engaging with MHK-DR team as well, and we engaged with them prior to this webinar. So our longer term goal or vision is to create a data ingestion pipeline. So we're having a second seminar on May 11th with regards to the data ingestion pipeline. But before we do that, we wanted to socialize some of the data standards that we have come up with based on the experience that we have had with other programs such as ARM and the WIND program, where we manage data as well. So I would encourage all of you to attend the second seminar, which is on May 11th at 11 a.m. And we will send out the PDF after this webinar so that you can register for that. Next slide. So the outline for this webinar is the first step is to understand the need for data standards, and based on our research, we wanted to provide you the data standards that we have come up with, and we wanted to socialize that idea with some of the subject matter experts and get their feedback. The second part of this webinar is the vision that we have for this domain in terms of the data standards and the data ingestion pipeline that we have built, prototype currently, supported by the Water Power Technologies Office. And then this will be followed by an example. Max will present the example where we have used the pipeline to test with the WIND program, and we'll show an example of how he's taken some raw data, ingested it, and standardized it, and we'll talk through that example. And then we'll follow up with a discussion at the very end. Next slide. So first off, I wanted to set the stage to what are the existing gaps within the program, or within data being collected from in the marine energy space. So currently, there are 3 different buoys or vessels that are being deployed by 3 different programs, and the data that is being, such as the flow rate and the direction of water that have been observed from these 3 vessels have been documented or collected as different variable names. So the first picture is from the A2E buoy that's been deployed in the marine in the coast of California. The second one is a vessel deployed by USGS, and the third one by NOAA. They all measure the flow rate and direction of water, but they are represented differently by the 3 different vessels. So the variables are itself incompatible across these systems. So obviously standardization is critical for this, and why is this very important? Next slide.
Okay. Oh, my the key controls are not working again. Hold on. Zoom is behaving. Okay. I'm going to reshare. I apologize for this.
So Karina, why don't I share my screen?
Yeah, I think you better, because I'm just having some real control issues with Zoom right now. It's like I can't use the keyboard. It's very bizarre.
Ah,
So I really apologize for that.
okay, I am not able to share either.
Oh, okay. I
So,
think I got my keyboard back. Let me try. I apologize. I mean, I have some problems with Zoom, but uh uh okay. Is it gonna come up? Okay, here it
ah,
is. There we go. Share. Okay. All right. We will try this again. Okay. There.
okay. So here's the visual about the data standards where you can have different shapes, different formats, different types of data. And the goal is to standardize them into a standard shape so that we can do some analysis with it. Karina, can you look through it? Okay. So the first step is, standardization helps in discovery, be it human and make it human and machine readable data, and it helps in mining the data as well. The other advantage for standardizing the data is to do the large scale analysis, and people can do research and advanced science. It also helps in machine learning. Machine learning is getting a lot of buzz these days, and having data in different formats is not helpful. We need it all standardized. It also helps when people do their science and they don't have to spend too much time wrangling the data. And I assume most of you are here because of that. And we will get to that very quickly. It also helps in automation, in discovery of the data, in transformation of data on demand. Say if it is stored in a particular format, can we automatically convert it to a certain type format of data? It helps in reuse of the code, and that's where we want to get to, where our second webinar, we will be presenting the framework that we have built, a Python-based framework or library where you can download the data, download the code, and run it through your raw data and make it and standardize the data as well. The last advantage to doing the standardization is ensuring consistency across data streams, just like I mentioned in the first slide, where the variable names are inconsistent, and we can it doesn't help in wrangling the data. And ultimately, where we want to get to is not only standardization, but actually improve the quality. As we collect the data, we want to be able to quickly decipher whether the data is within the normal range, whether it has failed a certain minimum or maximum range. And when we use it, say, in modeling, when we try to run some model using some observational data, sometimes we want to know, where did this data come from? So understanding the provenance of the data is very critical when we use observational data to run models. Next slide. Okay, so the vision that we have is where we have a lot of raw data, different kinds of input data. We want to run it through a data pipeline using certain configuration files or domain-specific algorithms, customizations. We use this pipeline to standardize this data and ultimately make it available in MHKDR or a data lake, where we can run additional analysis, run your own Python code, do some training for machine learning, or even transform and aggregate. You could take two sets of data, standardized data, and transform them into a common grid, or even average it and run additional analysis on those tools, on that data. So this is the vision that we have for this particular project. So we are going to be focusing on this standardizing. What standards should we apply once we ingest the data today? But the second webinar will talk about the pipeline that we have built, and we would like to continue to get feedback from the community on the standards, as well as how to improve the data pipeline. Next slide. So today, the goal is to review the draft data standards document. We welcome your feedback, and that's why we are here. We want to know what are the other relevant marine data standards and models that are out there. Potential use cases. Do you have raw data that we could use to standardize? And do you see any edge cases where we haven't thought about? So we would like some feedback about that. Our goal is to be able to standardize data sets from the raw format to the standard format. And we would want early adopters. If you are willing to share your data and give your expertise and want to download the tool, we welcome early adopters. And we also want to see if there's interest in forming a data standards committee among our members. So, there's always observations in this space that do not have standard names, and we'll talk a little bit about it. So a data standards committee, forming a data standards committee would be very useful, and we would then go back to this committee, a set of committee, to ask for guidance. So this is the goal of today's webinar. Next slide. Okay, I'm going to hand over to Karina at this point, who will be talking about the data standards.
Good morning, everybody. So I'm going to break the data standards down into like two categories. So the first type of standards are really generic, and they're baseline standards that could apply to any type of data. So for example, if you are getting ecological data measurements versus energy type of measurements, they would be generic enough that would apply to any type of data. So these are going to be things like, file naming conventions, standard format for the data, units, names, that kind of thing. Then we also want to allow the standards to be supplemented by more specific standards that are specific to the type of data. For example, wave energy. If you specifically want to have, when you are running a wave energy converter, and you need to have these specific measurements, and we want them to be in these units, and we want to have these statistics run, these computations, you have to perform these data quality tests. Those would be a supplemental pack just for that specific type of data. And so to just go over the baseline data standards a little bit more, because this is what we're mostly going to be talking about today. And we definitely want to encourage, we need people to help us to define the data models, and to also make sure that we've got the right baseline information. So we really encourage your participation and working with us to make these better. So our baseline data standards, basically, it's just going to be talk about it, the format. We want it to be really well supported and machine readable. And we want to talk about the general baseline metadata. We want to definitely capture metadata. So, basic information about your data set, how, the instrument and or sampling information, if it was, where the sampling occurred, geospatial metadata, any provenance information about how that data was obtained and any corrections that were performed on the data, and then data quality. So specifically, if these tests were run, if some of them were marked as suspect, we want to be able to identify that. And then we also want to cover, just the general standard unit conventions and variable naming conventions, and definitely file naming conventions, so that it's easy to tell what's in a file just by the name. And we also want, we'll go over again how we extend that with these data models. And so the data models, again, there'll be additional specific, much more specific specifications for a specific type of data. And we want to make sure that we're using all the right standards with these. We'd like to make it really easy to just look up the standards per data model, and they'll get, all the combined list of everything they need to do. And we want to make sure that we're compliant with all the relevant standards, and that we, make use of our MHKit toolkit for all the relevant computations that you might need. And so we would love to work with you to be able to define and prioritize these data models. So our long-term goal is that, we could identify ones that are really important, certain types of data that are being produced the most often, and maybe target those first. So now for our baseline data standards. So the first thing we want to go over is, file naming conventions. So you could look at the file and kind of tell what it is. And so the first thing about that is what we call the data level. So the data level is a measure for how processed the data is. And so we are using a convention that we kind of inherited from some other domains because it works really well. And so the use an identifier for each data level. And so the 00 identifier means that it is raw. It's raw data. Nothing's happened. It came straight from the instrument and or model. Then when you'll see later, we'll have these pipelines, we'll be able to process the raw data, and then they get converted into a standardized format, which we call an ingest. And the standardized format level is A1. So it means it has had some processing, it has been standardized, and it has been quality control checked. And then the next level down the road would be like when Chitra showed that big picture of the data lake, and you maybe want to aggregate and combine multiple data streams together, that we would call that a higher order data product. So that is data that has been pulled together from multiple sources, and or additional algorithms have been applied to convert the lower level geophysical measurements into the quantities that you would actually need to perform your science. And we give those a B1. So as the letters increase, you can tell that the data has been more processed. And so the way that is used in our file naming conventions, again, based on our experience, we're suggesting a format that similar to what we use in other programs like ARM for climate data, because it's very descriptive. And so I'll go through like an example of so this is an example of all the pieces of the file name and what they mean. So we usually have a location identifier, so some little phrase or word that you could easily tell where the data came from. Then we have the name of the data set itself. So, a descriptive name that describes the type of data that's being collected, if it's, buoy wave data or something like that. And then we give it an optional space to add any kind of qualifier you want. So sometimes you may have like multiple instruments at the same site, or multiple buoys, and maybe they're just differ by an ID number or something. And so that's what the qualifier would be. We also allow you to optionally add like a temporal resolution. So like if you have one set of data is being collected every 5 minutes and one that's collected every 10 minutes, you could put that in there if it helps. The whole purpose of this is just to help be able to distinguish the different data streams better. And then we have our little spot for our data level. That's the 2-digit level to determine how processed the data is. And then we also want to know like when is the data collected in this file. So we all recommend UTC dates that our pipeline will produce automatically. And so this would represent the date of the first data point in the file. And then we also include the first time. So if it starts at midnight, that would be 0. And then finally, we have the file extension. So, with our data pipeline that we'll be presenting on in May, you can export the files in multiple formats. And so that would just be correspond to the format that you chose. And so here's like a real world example of this. So if we have a buoy that's in Morro Bay, California, and it's taking wind measurements every 10 minutes, starting at midnight on December 1st, 2020, what would that file name look like? So we'd have our location ID that we decide to call it Morro, and then our data set name, that this is the ID for the buoy. So we just decide to use that because everybody in that project knows what that is. And then our qualifier is wind because we're specifically getting the wind data out at the buoy. And then it's being measured every 10 minutes. So we added a 10-minute qualifier on there, or temporal. And then because it's an ingest and it's just being processed from the raw and standardized, it's A1 level. And the date, the standard date format for December 1st, 2020, and then time is 0 minutes or seconds and minutes, hours, because that is it started at midnight. And then we decided to use our default file format, which is netcdf. And so that's the NC file extension. So now so that's kind of our file naming convention. Then the next step is, okay, well, what kind of file format should we use? And what criteria do we use when we want to think about which file format would work best? So we wanted to come up or to select a format that would be so generic that it would basically work with any type of data. It would be the most flexible. And so what are the flexible things that we were looking for? We definitely wanted to make sure that it supported embedded metadata so that the data is self-describing, and if anybody got that data in 10 years down the road, they would be able to know exactly how that data was produced and where it came from. We want to make sure that it is rich enough format that it can support any dimensionality of data. A lot of data is one dimensional and it can fit in a table, but a lot of data is not. It's, maybe dependent on time and depth. And so we need to, that's two-dimensional. And sometimes it may actually be three-dimensional if you have, also like bins and other things that are used to collect the measurements. And so we want to make sure that this format would support any of those. We also want to make sure that it can support any type of data, whether it's, observational data captured from an instrument or simulation-based data. We also want to make sure that the format had a lot of community support and was, a lot of community support and would have a lot of tools to be able to work with that data, and a lot of documentation, because that makes it a lot easier for people. And those tools would be, we want to make sure that there's lots of programming, all the programming languages that the users typically would use, like, Python, that there would be libraries to be able to read those files and interact with it intuitively. And that includes the really common Python scientific libraries such as Pandas, NumPy, Xarray, and Matplotlib. And so based on all those criteria and our past experience with other domains, we would like to use as our baseline format, our primary format, NetCDF, because it does all of those things. It's self-describing, it's machine readable, it supports any dimensionality, and it supports any type of data, and all the data quality and everything that we wanted to add in there. But we also wanted to ensure that that would not be the only format that was supported. That would be the kind of the baseline format, but you could also export your data in any format that was appropriate for the particular community and the particular type of data. So, and we've already done that for CSV and Parquet, and it is very easy to export into other formats, as long as, the dimensionality is compatible. So now I'll go over, so now that we're talking about the NetCDF type format, then we'll go over really quickly, like, what are the terminology that we usually use in dealing with NetCDF. So metadata, they call those attributes, and you can put metadata on the whole file describing your whole data set. So those are called global attributes, and or you could put it specifically on a variable, and they call those variable attributes. And then dimensions are just, that's how we refer to the points at which you collect data. We call that the shape of the data. So like time and depth, for example. And coordinates are special variables that contain the values for each dimension. So if time was your dimension, then you would have a coordinate variable of time, and it would have all of the time measure, like every 30 seconds or whatever, where the times were collected. And then all the rest of your data variables, they contain all your data in an n-dimensional array. And they also have their associated attributes that describe metadata about the variable. And so those are the actual, the scientific data that was collected. So now, one of the things in our standards is we would like to be able to have kind of like this dictionary of standard names, basically names of variables that are consistent across all data streams. So this is a way to be able to map one property, like in Chitra's original picture where she had those different buoy measurements that were different in each instrument. We'd like to be able to map those to like a standard name that represents that just specific property. And I know that climate data definitely has maintained a list of standard names, which I have a link here. NOAA has some standard names and measurements. They have, I think, like 30 some that they associate with general oceanographic data. And so we would like to be able to come up with the right list of standard names. So in this example, we found this from actually, because all those NOAA ocean measurements, they're all included in the climate community list. And so from this list here, we found, for average wave height, we found sea surface wave mean height from there. And the definition is right here. And it looked like that was the right, that was the measurement that was being captured in this data. And so this way would ensure that all your variables could potentially map, they could map to the same equivalent variable in different data streams. And that's really important for longer term analysis and being able to combine data meaningfully across multiple data streams. And so we are definitely encouraging anyone who would love to work with us and help us to come up with this list, the appropriate list of standard names for marine energy, because there's probably some additional ones that there may be many in here that we'd like to use, but there probably are some specific ones for marine energy that we should gather together. And then as part of our data standards, we would also like to generally identify what units we would use. And we just wanted to go with the UD units, set of units that are used heavily in climate, and because that's based on the SI system, and they're very thorough and well defined. And so here's an example, like where the height would be measured in meters. And then calling out here, UD units has a special, even though the time at the low level, when we actually normalize the time in the pipeline, it's just going to be UTC, and it'll be stored as like the epoch time. But for a nice easy reference, because it auto converts this, that you can just reference time as any type of unit since some origin time. So you could say, like, for epoch time, seconds since the epoch date. But you could also change it. In this example, you can make, if you need more specific time, you could say nanoseconds. So let's say you wanted to measure nanoseconds every day starting at midnight. You could do this kind of format, and you don't have to worry. They're all equivalent when they're read in and converted into the file format. They're automatically converted to the same long number, so you don't have to worry about any weird time conversion problems. So then the next thing that's really important in our standard is we want to define, how do we capture data quality? So the first thing that we want to specify is that all these variables that are stored in our file, they have metadata describing that specific variable. And one of the types of metadata they can have are quality control attributes. So these are like validity type, like in this case, valid range is anything, and anything outside of that measurement, we consider that invalid. Something went wrong with the instrument. Like if it's, time, and time is always increasing. If the time is a negative value, for example, that's not valid either. And so that's a quick way for some of the quality checks to be able to weed out values that are like completely wrong, and be able to alert people that they need to go look at something because probably something went wrong with the instrument. So you can embed, there's many different properties in the standards that describe these different types of quality attributes you can define on a specific variable. Then in addition to these attributes, we actually use those to run the quality control tests. And then all the results should be stored in a companion variable. So if your variable name was average wave height, then you would have a companion variable called QC average wave height, and that would contain all the results of your QC test. And and Max will go over this in more detail in the examples, but the QC companion variable will define every test that you had, what the meaning of the test was, what flags indicate whether the test succeeded or passed, and whether then you can go back and look. Then the next step is if the QC test had now flagged something as bad, and you, as part of your data pipeline, decided that, well, we needed to make a correction because of this bad data, then it also has a way to be able to actually identify that correction in the metadata, so that people would know that all of these variables that were flagged here because they were bad, maybe they decided to throw that value out and interpolate between the two adjacent values or something like that. So we want to make sure that we could capture what was checked and any corresponding correction that was applied following those checks. And that's a brief overview of our data standards that we covered in the baseline data standards. And now I'm going to pass it over to Max, and he's going to go over all of those things in a much more specific example.
All right. So next slide, please. So in this example, we're going to talk about some work that we did with a data provider in the wind energy space. And they had a buoy station in Morro Bay, California. And among other things, it took measurements of waves every 20 minutes. And the file that we're going to look at starts on December 1st, 2020. And so this is a real example, and we're going to be running this in near real time for processing this data on AWS. Next slide, please. So this is a screenshot of the first part of the file that I was given, initially with not much context. And so this is a CSV file. It's kind of in table format because I was using a special viewer to read it. But so I'm a software engineer. I didn't have a whole lot of context about what the headers meant. So like as ECM, I didn't know what that is. I still kind of don't. H average, T average. You can kind of guess what those are. H average is the average wave height. T average is the average period. So it's like tau average, and so on. But so the point here is that there's no information about the units for one. So I don't know if this is measured in meters or centimeters or feet for the height. For the period, it's you can probably guess it seconds, but it's not explicit. And so what I had to do is I had to go talk to this data provider and kind of work with them pretty closely in order to get all of that metadata in order to be able to use and standardize this data. Next slide, please. And so this is some of the metadata that I got. This is more just the global attributes. So we collected information about like what the title of the data set should be, description of the data set that is user-friendly, user-readable. And some of the other things in here are more for data provenance, like the conventions. So this is the version of the data standards document that Karina Tutor and I wrote. And that's the version of the data standards that this file conforms to. So you can always go back later on if you have this file and figure out what version was used to produce this. Similar thing with the code URL. You can tell what version of the code was used to produce this data. And we have some other things in here as well, like the location meeting, the data stream name, and the input files that were used to produce this data set. Next slide, please. Okay, so this is the standardized data. I'm not going to talk about the pipeline too much, or at all really, because this is just more about the raw data to standardized data. So our time variable is the primary dimension of this data set. So it is one dimensional, and each row represents a single measurement in time, or a single point in time. So our long name per time is time offset from epoch. So it's seconds since 1970, which is a CF standard wave of reporting time. And so our data for time in the standardized format is the actual number of seconds since 1970. And most viewers of NetCDF files will be able to read that and convert that to a date automatically. Next slide, please. Okay, and so for this example, the primary measurement that I wanted to talk about is the average wave height. And so on the left, we have the average wave height data, and on the right, we have the quality check for that variable. And so the first thing I want to point out is that on the bottom right, where we have the QC average wave height data, there's a 2. And this is the quality check. And so what this 2 means, if you look at the flag masks right here, you can see that this is the second flag mask. So it's the second QC check. And what this is doing is checking to see if the value of the average wave height is less than the valid range, then we're going to say that that value is has a bad assessment, meaning that we don't really trust that data. And so our valid range is defined over here, and it's 0 to 10. So anything outside of that range is considered bad. And so if we find a value outside the range, we'll add this corrections applied attribute. Karina had talked about this a little bit earlier. And this just says what correction we applied. So we removed values less than the valid range, and we replaced them with the fill value. And this is a climate forecast convention to represent data that is not assigned or that is missing. And so the original value here was actually, it was like negative 1.39, I think. And so we removed that and replaced it with the fill value. And what this does is it just tells your, if you're using like a Python library, this will be masked out as nan, so not a number. And that makes it a little bit easier to work with, because a lot of your algorithms will automatically ignore that number. Next slide, please. And so this is kind of the trimmed down standardized file that is output by this ingest. So we have our dimensions, which is just time. I've trimmed the output just 5 points, just for the sake of this example. We have our time variable. We have some of its units and some of its attributes and metadata. We have its values. Then we have our data variables. So this is average wave height and QC average wave height. The viewer I was using kind of turned off most of the names. That's a little bit unfortunate. But you can see that all of the metadata and attributes and data is all aggregated in the same place, in the same file. So it's pretty easy to just open this file, see your data, see its units, and know exactly what to do with it and how to work with it.
Great.
So yeah.
Thanks, Max. And I'll also add that there are a lot of additional things for working with your data that come with the data pipeline, which we will definitely be showcasing in our data pipeline webinar. For example, being able to easily see these quality control checks in a nice little graph format. So it makes it really, we have a lot of graphic type of capabilities that make it a lot easier to work with your data. And also, I wanted to also emphasize that all of this stuff gets written automatically by our pipeline. So we want it to be really easy to use. So the main thing that Max had to work with was the data provider was to get the metadata, the right metadata and units about the variables to use. And then all of this was automated with the pipeline. So we do want to make sure that everyone realizes that we're trying to make this very low maintenance and easy to convert all your data into the standard format so that there's not a lot of work involved on the user's end. So now what we want to do is we kind of want to open it up now for any questions or discussion from the community. We really are encouraging input to make sure that, so we've got a few topics here that we thought might be relevant, but if you have any additional topics, please feel free to bring them up at any time. So we're really encouraging community involvement to make sure that these standards are correct. Specifically, if you're aware of existing marine data standards and or specific, for specific types of data that we could evolve into a data model, we really want to know about them. We also want to know about your projects that you're currently working on. And if you have, need for standardization in your project, we definitely need data. So, and we don't have very much data. So we have lots of, wind data and climate data, but for marine energy, we don't have access to much. And it's the data that really helps us to flesh out these standards and make sure that they're good quality and that they're really relevant for all our different projects. So we really are looking to engage project team members to work with us that we can help you standardize your data if you would be interested. We would love it. And it would also help us make sure that our standards are appropriate for all these different use cases. And as part of that project work, we would kind of like to know if there's a general type, type of data that's being collected for most of the projects, or type of instruments that are being used. Would those benefit the most? Would those be the best to prioritize creating a data model for those? That would, if we could create a couple data models that were going to help, 80% of the projects, for example, that would be great. And if we could find people to help us to define those, we are really looking for domain experts to help us with that. And we can also potentially talk about, that Chitra had mentioned before, but we would love to try to form an informal committee to help us evolve the standards over time. And then any other, issues that that or questions that you guys have or concerns or anything about these data standards, please let us know. So we'll just kind of open it up now for audience participation.
So Karina, there have been a couple of chats from Jonathan suggesting we use the CF standards and metadata naming and formatting conventions, which was before the slides that you presented, which is great. I'm sure you haven't looked at the other chat message, a chat that he posted about the QC, which we will definitely look into it, which he suggested the QARTOD, which I have not heard of, but we will definitely do that.
Great.
So having said that, I also posted a link to the data standards document, which we forgot in this presentation, but it did come out during the registration process. So I will now open it up to other questions.
Great, thank you, Chitra. So we have a question here from Mark. Is this project looking to include cybersecurity standards, or is this just instrumentation data? I'm interested in the cyber-physical nexus between data supporting technologies and instrumentation and the linkages to marine energy cybersecurity standards.
Honestly, we have not considered it, but we will add it to a list of items and potentially talk to our program managers about it. Maybe we can start an email thread as to what your needs are. Was it Mark? Yeah, Mark. Definitely, we will definitely look into it, into the cybersecurity standards. Thank you for bringing that up.
Thank you.
Any other
yes,
questions?
thank you. Mm-hmm. Thank you very much for your presentation. May I talk?
Please go ahead.
So I'm Olivia Thiel. I'm working at Central Nantes in France.
Can help.
We have a test site for marine renewable energy. So we do have a lot of data of wave, wind, and current. And we are actually in a process of standardization and analysis of quality control of our data. Mm-hmm. So it's very interesting, this presentation and this work for us. So we could definitely provide either example of data file from wave buoy, or work on the definition of which kind of data we use, or be early tester, or I don't remember the word exactly, but early adopter of the pipeline.
Absolutely. So we have open sourced a pipeline, and I think we can get your email address and also send you a link to the pipeline, and you can download it. And essentially you would have to build a configuration file, like how Max worked with the data producer to define the variables and the units and how time was specified in the raw data, and we can help you through that process. We also manage a wind portal, a2e.energy.gov, and you're welcome to go look at it, where this data that he processed will be available. And it's open data, so anybody who registers can go ahead and download the data, and we have lots of standardized data within the wind program. So I will post the link on the chat box, and you're welcome to join the wind community. And we will also send the link to the pipeline where you can be an early adopter and provide feedback to us. That would be fantastic.
Yes, great.
Thank you.
Maybe a question. The levels of variable A1 and level A and B, are they stored in the same file? Is there only one file for raw and higher level data, or several files?
They are stored as separate files.
Okay.
So they and then the file name can let you can see they may be stored, in the same physical location in different folders, but each file, each level would be its own file, because often the columns, the names of the variables and stuff will change. So,
Yeah.
you know, the raw data will have whatever came off the instrument, like what Max showed. And then, you know, the standardized data would be, so for example, let's see. So it, you know, that the raw data, it would be HAV, but then in the, you know, the process data, it would be average wave height. So they wouldn't, so yeah, since the variables will probably all be named differently and stuff, they're just in separate files.
Okay, thank you.
Olivia, I would recommend you join us for the data ingestion pipeline. I will send you the link to the TSDAT utility, but we're going to demonstrate the pipeline in the second webinar on May 11th as well. So it'll be easy for you to understand.
Okay.
There was one question. Thank you, Haley, for putting the webinar link. And Max, would you put the link to the TSDAT utility too? One question came up from Jonathan. For localized data sets, do you still recommend against using local time instead of UTC? What if the time zone is clearly defined in the metadata?
Oh,
go ahead.
We prefer UTC. However, the pipeline will automatically convert it over for you. So it's totally fine if your original data is in local time. The pipeline converts it over to UTC, and then the UTC is what gets written into the final file, which just makes it easier to cross-reference between data streams.
Correct. Especially if you want to do additional analysis, say if you want to do machine learning, you want all data sets in the same timeline, same time zone. So it's easy to do the additional analysis. Other questions?
Should we send? We could we are recording this video, and we also will have a PDF form of the slides, so we can definitely send these out to everyone that was on this call afterwards too, so that if you want to look at this a little more detail, and feel free, you know, to contact us at any time if you think of something later as well, because we really appreciate the input and working with you. We're actually excited to work with people to try this out on different data streams.
We're looking for early adopters. So if you have raw data, please speak up so that you can test our pipeline and the standards. And if we have any edge cases, we would like to address it. So we have another question. Despite storing in UTC, do you support splitting output files to allow creating a file that contains all data for a solar day? Great question.
We don't preclude any, you could split your file however you wanted it. And right now what we do is we're doing a one file in, one file out type of processing. So, but you could easily add a customization to be able to pull in additional data. And so right now it's like, if you get, say your data is collected and you get one file every, like twice a day, every 12 hours you get a file, then the output would be 2 files every, you know, every 12 hours. You'd get, it's the same granularity of the files. But later, and as part of our, you know, our ongoing work with this data pipeline is that we're adding a support for higher level data products that can combine the lower level data. And so one of the things that we would be able to do, and that is what we're going to be working on next year, that's our next year's goal, is to be able then to aggregate the data over like a solar day. So you could still have your original files that got processed after, you know, every 12 hours, but then you would have like these higher level data products that would be running that would aggregate, say, over a solar day. They could aggregate, we could have ones that aggregate over a month if you wanted to, you know, just summarize the data over every month or every week, or however, you know, however was appropriate for the people that want to work with that data, how they want to see it. And so that definitely will be possible, but for right now, we're just doing the one file in, one file out mode.
I'm curious to see if any when are any modelers part of this conversation that where you're using observational data. I'm just curious. Okay. So do we have other questions? There's usually a 5-second rule.
Hey, Chitra, are there any plans to adopt a data dictionary?
Thank you, Haley. So, Karina, can you take that answer? Question?
Yes, yes. What we really want to identify, we definitely want to have data dictionaries. I think from what I've seen, a lot of the data dictionaries will probably be associated with the data, with specific data models. So what, for example, if you're collecting, wave energy data, you need to have all these specific variables, and this is what they mean. If you're collecting, ecological data sets, these are the types of variables that we want you to capture for ecological data. It seems like they'll probably be use case specific and relevant to the type of data being collected. So we will probably have more than one data dictionary. But we'll probably just organize them according to the data model. But we do not have we don't have any data models defined yet because we don't have enough data to be able to really flesh those out. So again, we would love to work with people with your data to be able to flesh some of those out. And if anybody, even if you don't have any data collected yet, but if you're on a project and you're going to be collecting data for a specific type, we would love to know about it. So it will help us if we can see across the board all the, as many projects as we can see and the type of data that they're going to be capturing. That will really help us to flesh out which things which all fall into the same category and would be a good candidate for a data model. And I also mentioned too that, we have been communicating with the MHKDR team, and it is our goal that, all the data that goes into MHKDR will also be utilizing these pipelines. So that way, all the data, and so we'll also get more information from the MHKDR team to help influence what these appropriate data models should be.
Thank you, Karina. Okay. 5 seconds. Who is on the MHKDR team? Who is on the MHKDR team? Was one question. We worked with John Weers at NREL, and he has a larger team within NREL. Maybe Rebecca, can you answer that question? I don't know. Is Rebecca on the call? We socialized this document with John Weers and some of the MHK team, Mark. I don't know who are the other team members within MHKDR. Maybe Haley knows. Haley, do you know?
I think I was just, yeah, that's good. I wanted to know if there was anybody at the lab that it was socialized with for MHK. And then, I've been supporting Marine Renewable Energy cybersecurity standards for the last year and a half, and through funding from WPTO, Water Power Technology Office. So we've worked with Tethys and PRIMRE to publish our stuff, and we've talked before. So this is all very interesting. I think when we think about standards, we're thinking about standards from the technology aspect and standards from the protection aspect, and this this convergence is very, very fascinating. It's the same kind of challenges that we see in operating technologies and in other completely other domains, right? But that still have a convergence to cyber. So I'm just interested in when you say MHK, and I thought you said DR, who else was involved, because we've crossed paths in our conversations from our projects with other people in MHK, and just want to make sure that either we're talking to similar people or not the same people at all. It's just interesting to gather that information.
Yeah, so the MHK DR stands for Data Repository, and it's led by John Weers, and I don't know who else is in his team. I know he invited others in his team, and I can follow up with you about that. But it would be good maybe to talk offline as well.
Sure.
And you know, there's
Absolutely.
there's a lot of overlapping issues, I think, between the two projects.
Okay.
And John's team did OpenEI, which is a very large
Oh,
data
okay.
repository. Yeah. And
Oh,
so
yeah.
they've worked with all kinds of domains and
Very cool.
yeah. So he'd be a good contact person.
Mhm.
And also, you know, the things we're looking for, you know, in these data standards is really to have the right information in the data so that it can be reusable. So this is, we're thinking long-term reuse, because what happens usually is you have some data that you know what it is now and you can do your analysis now, and then you put your data out in a repository, and then if somebody comes along in 2 years, they can't use your data. There's not enough information there. It's like they don't know if they could trust your data, you know, if the data quality is good or not. And so a lot of data just sits out in a repository and it can't be reused. And that's really a problem, especially now when machine learning is becoming, you know, it's just so helpful and it's so valuable in being able to predict things. And if we can't read the data, then it's not going to really hampers machine learning. And so these are kind of the things that we were initially thinking of as supporting, you know, and I think, you know, the cyber information is it's such a huge area. I think that would be an excellent candidate for a data model.
Yeah, and there are some industry accepted formats now for information, not just information sharing, but in archiving data, cyber protection data. So when you look at an organization, any organization can assess themselves given a standardized formats that that government has accepted and the industry is following. So it's pretty trend setting, and that's been the last year and a half. So we have a team, a software development team at the lab working on data ingestion of multiple different cyber data sets that follow this very specific formatting that I'm talking about. So I won't get into it, but anyway, that's why this is fascinating also, because having nothing to do with MRE or MHK, we're exploring this data concept similar to what you guys are doing, but from a cyber perspective about integrating just the mother load of data that can be used from years from now, because it has a long-term mission as well. So this is very fascinating research. Thank you.
Thank you, Mark. We are 2 minutes past 12. Please go ahead and send us an email if you have additional questions, but we look forward to seeing you on May 11th when we will demonstrate the data pipeline. And if you have data that you want to standardize, please send us an email as well. We did not put our email address, but you might, I'm not sure, but you can reach us through THIS or some other means, but I will put my email address here as well. Thank you all for joining and have a great day.
Thank you, everybody.
Bye. Thanks, Karina. Thanks, Max.
Everyone.